Unit 7, Day 1, the Pythagorean Theorem and its converse. Unit 7 is all about right triangles, and the Pythagorean Theorem is used to help find the side lengths of right triangles. So we have to start off with a right triangle, and then so we have to find that right angle. The two sides that make the right angle, this side and this side, those are called A and B. It doesn't matter which one's which, but the legs have to be A and B. Then this side C, the one that is opposite from the right angle, this side is what we call the hypotnuse. This one has to be C, because when we have this equation a squared plus b squared equals c squared, A and B, the two legs can be switched, but the hypotnuse always has to be C. So just make sure you're very careful when you're assigning the letters A, B, and C. When we talk about proving the Pythagorean theorem, there's a website that we're going to use to help us kind of visually understand what we're talking about. This website is going to help us demonstrate the Pythagorean theorem. It says to think of each side of a right triangle as also being a side of a square that's attached to the triangle. The area of a square is any side multiplied by itself. In the diagram below, we're going to show that a squared plus b squared equals c squared by moving the smaller squares to cover the area of the big square. So we have this right triangle with the two legs A and B, and the hypotnuse is C. They've just designated for side A to be 4 blocks, so we have 4 blocks, and then the area, 4 times 4, or A times A, is going to give us 16. So we're going to take these 16 and move them in there. Then this side B, we have, using that same measurement, we have 3 across and 3 down, which gives us 9. But when we try to move this over, it won't fit as it is. So we're going to need to break this up and move it over one at a time. And then you'll find that this is going to fit exactly. Now this isn't a formal proof, but it's just a visual demonstration of how if you were to take a squared and b squared, it'll equal c squared. Now let's work through a few examples. Here we're going to solve for the hypotnuse. So we're going to start off with our Pythagorean theorem, a squared plus b squared equals c squared. And then we need to look at this. Here's our right angle. This is the side that's opposite, so that means this one has to be C. So 5 and 12, it doesn't matter which one's A and which one's B, but we're going to substitute those values in. A is 5, B is 12, and our C is actually going to be our X. So we're going to square 5 to get 25. 12 squared is 144, and that gives us X squared. Then when you add 25 and 144, we get 169 equal to x squared. Now, to isolate the x, we have to take the square root of both sides. Sometimes when you put this in your calculator, like this one, square root of 169, you'll get a nice whole number, 13, is equal to x. Okay. Now remember, once you take the square root of both sides, these cancel out, so don't put that square root there anymore, okay? And also don't put the squared, it's just x equals 13. Here's another example. Again, we're going to start off with a squared plus b squared equals c squared. And again, here's our right angle, this is the side opposite, so this has to be our c. Doesn't matter which one's a or b. So we have 2 squared plus 1 squared equals x squared. 2 squared is 4, 1 squared is 1, equals x squared. 4 plus 1 is 5, equals x squared. Now, when we take the square root, when you put square root of 5 in your calculator, you're actually going to get a decimal. Those cancel out, so we're left with x on this side. Instead of writing a decimal, I always want you to give this to me simplified in radical form. Now, square root of 5 cannot be simplified because 5 is a prime number, so your final answer is just square root of 5. Now, in these problems, we're going to do a couple examples while we're solving for a leg. Now, you're going to use the same setup, a squared plus b squared equals c squared. But this time what ends up happening is across from the right angle, we have the hypotnuse, and this time the hypotnuse is 10. And again, doesn't matter which one's A or B, but when we substitute in, we get 8 squared plus x squared equals 10 squared. So the only thing that's different is our x is over here instead of on this side by itself. But we're just going to solve this equation like we know how to do. 8 squared is 64 plus x squared equals 100. Then subtract 64 from both sides. And we're left with x squared is equal to 36. Now, take the square root of both sides to isolate. Cancels out and we're left with x. Square root of 36 is 6. Now when we do this example, same idea. We start off with a squared plus b squared equals c squared. And then across from the right angle, we have 9 is c. So that means a and b. So we substitute x squared plus 7 squared equals 9 squared. X squared plus 49 equals 81. Then we want to subtract 49 from both sides. And then we get x squared is equal to 32. Now, when you take the square root of both sides, this cancels out and we're left with x. But when you put this in the calculator, you're going to get a decimal. That means we need to try to simplify this radical. So remember, when we simplify, we want to break this down. 32 is equal to 4 times 8. 4 is equal to 2 times 2. 8 is equal to 2 times 4. And then we can break down that 4 one more time. Bring down all these 2's. And that 4 breaks down to 2 times 2. So when we're trying to break people out, they pair up. One gets out, one does not. They pair up, one gets out, one does not. And then this guy doesn't have a partner, so he's stuck inside. Then, since these two numbers made it out, we're just going to multiply. And your final answer is going to be 4 times the square root of 2. Okay. So we practiced simplifying radicals before, and we need to keep working on that. Okay. Pythagorean triples. This is just something you need to be aware of. It's when you happen to get side lengths of a right triangle that are all whole numbers. So you'll see in this example that we talked about, we have side length 9, 7, and then 4 square root of 2. This is not a whole number because when you put this in the calculator, you're going to get a decimal. So those side lengths 4 root 2, 7, and 9 are not a Pythagorean triple. These sets are some of the basic ones. You don't have to memorize these, but knowing them can help you make some of your calculations a bit faster. Now we want to talk about the converse of the Pythagorean theorem. We know that if c squared equals a squared plus b squared, then triangle ABC is a right triangle. If I give you other side lengths, and when we find the calculation that c squared is less than a squared plus b squared, what we're going to find is that this angle C is actually an acute angle. If we have side lengths so that c squared is greater than a squared plus b squared, then that means that this angle C is going to be an obtuse angle. So we're going to work a couple examples just to make that more clear. First, it says to decide whether the numbers can represent the side lengths of a triangle. That's what we did in Unit 6, where we test the two shortest sides, 21 plus 28, and that is going to equal 49, which is greater than 35. So these three side lengths can make a triangle. Now, when we want to classify the triangle as right, acute, or obtuse, we're going to use the converse of the Pythagorean theorem. And that I want you to set up like this. C squared box a squared plus b squared. Now, when we're substituting in for c, it always has to be the biggest number. 35 is the biggest, so that has to be c. A and b, doesn't matter which one's which. So we're going to substitute in 35 squared, box, 21 squared plus 28 squared. 35 squared is 1225. 21 squared is 441. And 28 squared is 784. Now, this side's still 1225. When you add 441 and 784, you get 1225. So what ends up happening is that when you compare c squared and a squared plus b squared, they are equal. So this is actually a right triangle. And that would be your answer. Now let's take a look at the next one. So we want to test whether it's a triangle. So take the two smallest, 10 plus 2, and that equals 12. Because 12 is not greater than 12, these side lengths do not make a triangle. And you can stop there. When we take a look at this one, the two shortest sides, 10 and 11. 10 plus 11 equals 21. 21 is greater than 14, so these do make a triangle. Then we want to take a look at our Pythagorean theorem converse. Sorry. I actually want to write c squared box a squared plus b squared. And then when we're assigning, we want the greatest one to be c, and then again a and b, doesn't matter which one's which. So c is going to be 14, a is 10, and b is 11. 14 squared is 196, 10 squared is 100, and 11 squared is 121. Then we have 196, box 221. Now, 221 is bigger than 196, so that means that c squared is going to be smaller than a squared plus b squared. This means we have an acute triangle. So when c squared is smaller, it's acute. Let's check the last one. So we have square root of 5, 5, and a decimal 5.5. In order to decide whether it makes a triangle or not, we actually need to find the decimal for this. So when you take the square root of 5, this is approximately 2.2, and that's just rounded. So you just want to use that as an idea. So when we test, we can test 2.2 plus the other smaller number 5. This is equal to 7.2, which is bigger than 5.5. So this makes a triangle. Now, let me move this over a little bit. And then let's do our Pythagorean theorem converse. C squared box a squared plus b squared. And then when we assign our values, c is the biggest number. So since this is 2.2, 5, 5.5, this is our biggest, then we can put a and b. So c is going to be 5.5. A, now be careful. Square root of 5, I need you to put it in just like that. Okay? Do not use 2.2. That will give you a very different answer. And then we'll put in 5 for b. 5.5 squared is 30.25. The square root of 5 squared, those are going to cancel each other out, so we're left with 5. And then 5 squared is 25. So we have 30.25 box 30. And then when we compare this, just barely, c squared is greater than a squared plus b squared. So in this case, we're going to have an obtuse triangle. Okay. So this is why I want you to set it up c squared box a squared plus b squared. Because if c squared is smaller, it's an acute triangle. If c squared is bigger, it's an obtuse triangle. If c squared is equal, then it's a right triangle. And we're done.